Hello, lovely people. I hope you are doing well. Just going to give some love to the A-level students. So I'm going to go through this question relating to parametric equations. It's one of the questions that people find particularly challenging, which is understandable because we're very used to working with x's and y's and only x's and y's, whereas parametric equations involves this third variable, or sometimes even a fourth variable in some cases. So let's go. First question is to find an expression for dy dx in terms of the parameter t. Okay, so the first thing that we need to know is that using chain rule, dy dx can be given as dy dt multiplied by dt dx. Now, if you think about this as fractions, that kind of makes sense, right? Because the dt's would cancel like this, leaving dy dx. Okay, and that is another way of writing that, understanding the way fractions work, is by doing dy dt divided by dx dt. It means the same thing, okay? So we know that y is equal to 2 sine squared t. So therefore, dy dt, we're going to differentiate using chain rule. So I will go through the chain rule slowly. So I will let u equal sine of t. Therefore, I have that y is equal to 2u squared. And I'm going to work out what dy du is. That's equal to 2 times 2 is 4, u to the power of 1. And also, from this, I can also work out that du dt is equal to cos of t. So, all in all, to get my dy dt, that's going to equal, by chain rule, dy du multiplied by du by dt. Now, dy du we worked out was 4u. And du dt was equal to cos t. Now u is equal to sine t, so that's equal to 4 sine t cos of t. So that's that bit done. Okay, now let's work out what dx dt is. So x, first of all, was equal to 2 cot of t. So dx dt, well, using knowledge or using the formula sheet, or however you want to do it, we should know that cot, so the differential of cot is minus cosec cot, like that. So therefore dx dt, given that x is 2 cot t, is minus 2 cosec t cot t. Okay, and then that means that dy dx in general, let me just separate this, dy dx is going to be equal to our dy dt divided by dx dt. So dy dt was equal to 4 sine t cos t. And then our dx dt was equal to minus 2 cosec t cot t. So this is an expression, this is good enough, but I'm just going to simplify it a little bit more because we are going to use this for more parts of the question. So we've got 4 sine, well, first of all, actually, no, not even that. We've got the 4 divided by minus 2 is minus 2. We've got sine t cos t, all divided by, we've got the cosec t, which is 1 over sine t. And we've got cot t, which is cos t over sine t. Now, simplifying that, Dividing by 1 over sine is like timesing by 1 over sine. So you've got that twice, 1 over sine t and the cos t over sine t. So that becomes minus 2 times the top by sine t twice. So times by sine t and then times by sine t again, giving us minus 2 sine cubed of t. And then you've got cos t divided by the cos t, which just leaves you with 1. So it's just minus 2 sine cubed of t. Okay, so that's our simplified expression for dy dx. Right, we kind of see why people find this a bit tricky, because it's a bit fiddly. But if you're careful and with some practice, it does get better, I promise. Okay, so let's change to orange maybe. Actually, orange is not a very good color. Let's change to green. Green isn't that great either in this case, but it's fine. Find an equation of the tangent to the curve at the point where t equals pi over 4. So, first of all, we need to work out the coordinate that represents. So at t equals pi over 4, well, we know x is equal to 2 cot t. So x equals 2 cot of pi over 4. And that is equal to 2 over tan of pi over 4, because cot is 1 over tan. And tan of pi over 4 is just equal to 1, so that's actually just equal to 2. So we've got the x coordinate as 2. And in particular, we also know that y is going to be 2 sine squared pi over 4, or sine of pi over 4 is root 2 over 2. So that's equal to 2 times root 2 over 2 squared, which equals 2 times root 2 squared is 2, 2 squared is 4, so that's equal to 2 times 2 over 4, which is equal to 1. So we've essentially got the coordinate 2, 1. So that's the first thing that we've worked out. We've got our expression for dy dx, so we need to know the gradient. So at t equals pi over 4, dy dx is equal to minus 2 sine cubed of pi over 4. So that's going to be minus 2 multiplied by, so we know sine of pi over 4 is root 2 over 2, so that's root 2 over 2 cubed. And that's equal to minus 2 times by root 2 cubed is 2 root 2, and 2 cubed is 8. So that's equal to, minus 4 root 2 over 8, so minus root 2 over 2. So that's the gradient. So we've got that. So we've worked out the gradient. We know the coordinate. So we've got that our equation of our tangent is going to be equal to, let's use brown. I don't know if this would be a great color, but whatever. Y equals mx plus c. We know our gradient is equal to minus root 2 over 2. So it's y equals minus root 2 over 2 x plus c. And to work out what the c is, well, we need to use the coordinate 2, 1. So we use 1 is equal to minus root 2 over 2 multiplied by 2 plus c. So 1 is equal to minus root 2 plus c. So therefore c is equal to 1 plus root 2. So overall, we have y is equal to m, which is minus root 2 over 2 x plus 1 plus root 2. That's our final equation, our straight line. So we needed to work out the gradients, we needed the coordinates, and then we used y equals mx plus c. Lovely stuff. Next, it says find a Cartesian equation of the form y equals f of x. State the domain in which the curve is defined. So there are two parts to this. Let's actually just work out what the Cartesian equation is. So Cartesian is without the t's, it's just x's and y's. So let's change this. So let's start our part C over here. I'm just going to restate what facts we had. So we had that x was equal to 2 cot t. X equals 2 cot t. And y was equal to, was it 2 sine squared t? It was 2 sine squared t. Let me just do a little insanity check. Yep, 2 sine squared t. Okay, so what we're not going to do is we're not going to do the whole take inverses to get t by itself. That's not how we do this question. Please, please, please don't believe that that is how we do it, because it's not. we are going to use trigonometric identities. And what I'm seeing here is I'm seeing a sine squared and I'm seeing cot. Now, where's the relationship? Well, I do know this identity. I know that this identity is true. I know that 1 plus cot squared of t is equivalent to cosec squared of t. And cosec squared, remember, is 1 over sine squared t. That's how things are linking here, okay? So what I can do is say that y over 2 is equal to sine squared of t. That's useful to us. If I take the reciprocal of both sides, I get that 2 over y is equal to 1 over sine squared of t, which tells me that 2 over y is equal to cosec squared of t. That's useful because we can then put that into this identity. Equally, with this, I can say that x over 2 is equal to cot of t, which means that x over 2 squared is equal to cot squared of t. So now that we've used those identities, we're good. We just make the substitutions. So 1 plus, not cot squared of t, but x over 2 all squared is identical to, and we've got not cosec squared t, but 2 over y. So that's going to be just equivalent to 2 over y. And they wanted us to have it in the form y equals f of x specifically. So we are going to do that. So we have to get it as y equals, so that's y. Okay, so I'm just going to rewrite this. So maybe not with the identity because they're not identical to one another. I'm going to write this as 2 over y equals 1 plus, well, x squared over 2 is, x over 2 squared, sorry, is x squared over 4. If I take the reciprocal, in fact, I'm going to make this a little bit nicer. 2 over y, add the fractions, I get 4 plus x squared all over 4. Then I'm going to take the reciprocal of both sides, giving me y over 2 equals 4 over 4 plus x squared. And then times both sides by 2, so I get y is equal to 8 over 4 plus x squared. Okay, so now the other part is to keep in mind what the domain is. So here we've got the domain is that t is in between 0 and pi over 2 specifically. Okay, that's fine. So just thinking about how we're going to get that domain for our value. So if t is in between 0 and pi over 2, so let's just write the domain. 0, is it less than strictly? Yes, strictly less than t, less than 0. So yeah, strictly less than t, less than or equal to pi over 2. Was it pi over 2? I have to just check. Okay, yeah, cool. All right, so if that's the case, then for sine squared, well, we know that the lowest value is going to be sine 0, and the highest value is going to be sine squared of 0, rather, 2 sine squared of 0, and the highest value is going to be 2 sine squared of pi over 2. So that means that y is going to vary, and it's going to be between 0 and 2, because if I substitute 0 in, which we can't really have, but it would be 0, because t can't actually be 0. And if we were to substitute pi over 2, that gets you the highest possible thing, which is 1, and everything in between is going to be between 0 and 1. For x in particular, though, that's where things are a little bit different. So x equals 2 cot t, which is the same thing as 2 over tan of t. So, okay, now we understand why t couldn't be equal to 0, because you'd be dividing by tan of 0, which is 0. You can't divide by 0. So if I substitute tan, oh, I see. Okay, so when Okay, so with cot, as it's close to 0, it's quite close to infinity for the cot graph, I guess. Yep. And at 90, that's where it's quite close to 0. So the graph looks something like this. So that makes sense. So that essentially between 0 and pi over 2, that's essentially from 0 up to infinity. So that's basically everything greater than 0. Okay, so basically x is essentially greater than 0. Always. Okay, so x is always greater than 0 is what it's telling us. And if this is true, that means that we've got here y equals, here that is, we've got y equals 8 over 4 plus x squared. Well, the smallest that could possibly be is going to be, so smallest is at, well, technically greater, but 8 over 4, that's like the lower bound, if you like, because that's when you substitute x equals 0. So we know that, oh, actually, no, they were asking us for domain, weren't they? Were they asking us for domain? Yes, it says state the domain, that's it. So actually, it's just the x. So for domain, we're just looking at x, not even the range. Never mind, so we've done all the question. Yeah, it's simply just that x is greater than 0. Because between 0 and pi over 2, which is about here, that's how it's defined. So the domain, so this is the Cartesian equation, and the domain is that x is a real number, specifically where x is also greater than 0. That's it. So quite a few things to learn there, quite a few different topics to cover there, mixed in one. So it was parametric equations, but also domain came in there, trigonometric identities came in there, differentiation came in there. So hopefully it's a very rich problem to help with revision. Take care, guys.